Hello students of Year 11 Maths General and welcome to exercises 4G and 4H from your textbook. I've put both of these textbook exercises together into one video because they're both about finding the equation of a straight line from its graph. Now just as a reminder before we look at these techniques, the equation of a straight line, the general form is y equals mx plus c, the slope-intercept form. Now remember y and x, they're just variables that represent the different coordinates of points on the line. But m and c will never change for a given straight line. So every straight line has its own m value and its own c value. Remember, m is the gradient and c is the y-intercept. And what that means is where the line goes through the y-axis. So what this means for us is to find the equation of a straight line, all we have to do is know those two things. We have to know what is the gradient of the straight line and what is its y-intercept. So both of our techniques revolve around finding those two pieces of information. Let's take a look at them now. So the first of these techniques is from exercise 4G. And this technique says to read the y-intercept from the graph. So this is a situation where the y-intercept is clearly marked for us. And then we need to calculate the gradient using 2 points on the graph. The advantage of this technique is that it's actually quite easy to do, because as long as we can calculate gradient, the y-intercept, the c value, is free for us. All we have to do is read it from the graph. Now this is easier, but like I said, it requires that the y-intercept is labeled on the graph. So if the y-intercept is not labeled in the graph, we can't use this easier technique. Now our second technique is from exercise 4H. And in this technique, we have to calculate the gradient first. So we calculate our gradient using 2 points on the graph. And then we have to calculate the y-intercept by substituting one of the 2 points into the equation. Now this technique is a little bit more difficult because it involves some substitution and some algebra. It's still very doable though. And like I said, this technique doesn't require that the y-intercept is marked on the graph. So it can be done with any 2 points. Let's take a closer look at the 4G method now. So for the 4G method, like we said, we identify the y-intercept and that gives us c. Then we use 2 points on the graph to find the slope and that gives us m. And then we're actually finished. All we have to do is rewrite y equals mx plus c, but we replace m with the slope and we replace c with the y-intercept that we've found. So let's take a look at that in an example now. I'm finding the equation of this straight line graph here. Now, like we said, we want to know what is the y-intercept first, and here we can see it's clearly marked on the graph. That's where it intersects the y-axis, and this point here is 0, 2. Alrighty. Now, the y value of this is what c is. The c is the y value, because the x value of all x-intercepts is 0, because that's where the y-axis is. It's at x equals 0. So anyway, like we said, that means that c is equal to 2. Now that I've found the y-intercept, I need to calculate the gradient. I need to calculate m using 2 points on the graph. Now you might think there's no second point is marked on this graph. That's okay though, because as long as there's a point on this graph which intersects the grid lines, I can use it as a second point. And this point up here, it intersects the grid lines that are marked on the graph. Because I need to use this point here because I know that its x value is 5, and I know that its y value is 9. Alrighty. If I was to choose some other point on the graph, like maybe this one here, I'm not really well, this x value I can clearly see is 2.5, but I'm not really sure what this y value here is. It's between 5 and 6. It looks like it's 5.8, but I would just be estimating. We prefer to use a point like the one at the top right that I've marked, which is clearly 5,9. I can't be wrong about that because it intersects the grid lines. So now that I've got that point, I can do my m calculation, my gradient calculation. And remember, gradient's equal to rise over run. Alrighty, so between these 2 points, all I need to look at is how far does it rise to get from this point here to the second point. And the y value of the first point is 2, and then it rises up to a y value of 9. So that's risen by 7. Now the run, it tells us how far does it run across in the x-axis to get between those 2 points. And it starts here at 0, and it ends up at 5. So it's run across by 5. So I've got a c value, and I've got an m value. That's all I need to do, because the standard form says that y is equal to mx plus c. And m in this case is 7 over 5, and c is 2. Oops, sorry, c is 2. So that means the standard form, the slope-intercept form of this straight line is y equals 7 over 5x plus 2. So that's the equation of that straight line there. So I can actually label it in the diagram as well. Y equals 7 over 5x plus 2. Excellent. That was a 4G example. Let's take a closer look at the 4H method now. And like we said, with the 4H method, you have to calculate gradient first and then calculate the y-intercept from there. So, of course, that means first we need to use the coordinates of 2 points to determine the slope. Then we substitute this value for the slope into the equation. Because it's y equals mx plus c, once we put m in, only c is an unknown now. Then we choose one of the coordinates of the 2 points on the line and we substitute that into the equation as well. And that will tell us what c will be once we use some algebra. And then after we've done that, it's just like before, we substitute both of the values, the m and the c value, into y equals mx plus c, and we're finished. Now there's a little note down here. It says this method works in all circumstances, because as long as there's 2 points, we can find the equation of the graph. And if there's less than 2 points, no one could possibly find the equation. So here we go. I've got an example here where 2 points are clearly marked on the graph for me, but neither of them is the y-intercept. So I can't just start by saying c equals something. I'm not really sure yet, because I don't see where c intercepts the y-axis there. Alrighty, but I do have 2 points. So like we said before, I can do a gradient calculation. So m is equal to rise over run. And this first point, it has 1 in the y-axis, and it rises up to 10 in the y-axis. So that's a rise of 9. Now the run, it goes from 2 in the x-axis up to 4 in the x-axis. So that's a run of 2. So just like before, this is a fractional answer, and it can't be simplified any further than it already is. So the gradient here is 9 over 2. So now I'm going to substitute that into my equation. So I'll have y equals 9 over 2x plus c. Okay, so I'm not quite finished yet. Obviously, I still need to know what c is equal to, but this is my equation so far. Y equals 9 over 2x plus c. Now what I have to do is to choose one of these 2 points, and I need to substitute it into the equation. So I'm going to choose this point here because the numbers are slightly easier to work with. So then I'm going to write at the point 2, 1, x equals 2, and y equals 1. Because I'm going to use these 2 values here, I'm going to substitute them into this equation. And once I've done that, there won't be any letters left over except for c. So that means we've got a line of linear algebra, which we can solve to find out what c is equal to. So let's do that now. We're substituting this into our equation. So now y equals 9 over 2x plus c will become y turns into 1. So that's 1 equals 9 over 2. And x has become 2 because it says just here x equals 2. And then I have plus c left over. So let's simplify this a little bit. I've got 9 divided by 2 multiplied by 2. So that's just going to turn into the number 9 because the 2's cancel. So I've got 1 equals 9 plus c. So 1 equals 9 plus c. I want to get c on its own, so I have to subtract 9 from both sides. And I'm just unfortunately going to have to move my working up here. So I've subtracted 9 from both sides. 1 take 9 becomes negative 8. And then on my right-hand side, I've got 9 plus c take 9. So the 9 and the take 9 cancel each other. And I'm left with c. So what I've got here is c is equal to negative 8. So now that I've got m and c, I'm finished. Because now I can say, therefore, y equals mx plus c. In this case, it's y equals 9 over 2 x plus negative 8. Or y equals 9 over 2x minus 8. So that's the equation of the straight line that's marked on the graph above. Y equals 9 over 2x minus 8. Alrighty, here's a second example for exercise 4H. So I'm going to be determining the equation of this straight line using 2 points, and neither of them is the y-intercept. So remember, we need to start by finding the gradient. M equals rise over run. And the difference with this straight line is that it has a negative gradient. So it's heading in the negative direction as x increases. So my rise, I start off with 7 in the y-axis, and then I end up at 4. So the difference there is 3, but it's not positive 3 though, because I haven't risen by 3. I haven't gone from 7 to 10. I've gone from 7 down to 4. So I technically have a negative rise. So I have a negative rise. I have negative 3. Now my run, I'm going from 2 in the x-axis to positive 5. So that's actually an increase of 3. So my run is still positive. So what this means is I've got negative 3 divided by 3. The 3's cancel each other out, and I'm left with negative 1 as my gradient. So that means I can rewrite my equation as y equals negative x plus c, negative 1x plus c, instead of mx plus c. Now from here, I still need to find out what is the c value. So I'm going to substitute in one of these 2 points. And I think I'm going to choose 2, 7 to be the point, just because the x value is slightly smaller here. So I've got at 2, 7, x is equal to 2, and y is equal to 7. So therefore, instead of y equals negative x plus c, I've got 7 equals negative 2 plus c, because I've replaced y with 7, and I've replaced x with 2. So I've got negative 2 here instead of negative x. So 7 equals negative 2 plus c. To get rid of the negative 2 and have c on its own, I need to add 2 to both sides. So on the left-hand side, I have 9, and on the right-hand side, negative 2 and plus 2 cancel each other out. So what I found is that c is equal to 9. So therefore, I can say y is equal to mx plus c, and because I know m is equal to negative 1, that's negative x, and c is equal to 9, so that's plus 9. Y is equal to negative x plus 9 for this graph. So that's the equation of this graph here. Y equals negative x plus 9.